Okay, so we're gonna find the solutions to each equation mentally. So how many real solutions does each equation have? Okay, so if I'm gonna solve this first one, I'm gonna do what to get rid of this square right here? What's the opposite of squaring something? Taking the square root. So if I take the square root of both sides, that's gonna give me x equals +2 and -2. Okay. Another way you're going to see this answered is positive and -2. Okay. So how many real solutions does that one have? 2 real solutions. The same thing is going to happen on the next one. I'm going to take the square root of both sides. What's the square root of 9? 3. So we're going to have a positive and -3. And so how many real solutions am I going to have? 2 real. What about the next one? Well, when I take the square root of both sides, what's the square root of 0? It's just 0. So how many real solutions do I have? 1 real solution, right? Now, on this last one, when I take the square root of both sides, what's the square root of -1? Well, if we type that into our calculator, it says error. Okay, so what that's going to mean is we have no real solutions. And that's what you learned back in Algebra 1. Okay, so today we're going to talk about complex numbers. Okay, so I would title, if you're just taking notes on a piece of paper, we're going to talk about complex numbers. Okay, so looking at this, numbers on the number lines are often called real numbers. Let's represent the real solutions to the equations you solved earlier on this number line. Okay, so when we take the square root of both sides, we got x equals positive and -2, right? Well, on a real number line, we're just going to plot 2 and -2. Okay, again, we're going to do the same thing for this one. And this is what we solved on the last page. Okay, we would have solutions at -3 and 3. This last one was 0. Now, when we took the square root of this, it's actually going to be off of the real number line. So it's actually going to be up here. And we're about to talk about this in just a second. So this is going to be the square root of -1. Okay, because it's not a real number, it's going to be off of the real number line. And all of this will make sense in just a second. If you're sitting there and you're like, what? Okay, remember, real number line is what we're used to. Okay. All right, so looking at this next part, imaginary numbers. Does anybody need this? Sorry, I know I'm moving quick. All right, so the square root of -1 is the solution to x squared equals -1. The diagram shows an arrow that represents the square root of -1. Okay, so draw an arrow starting at 0 that represents 3 square root of -1. So what we're going to do is we're going to start at 0, 0, and we're going to go up 3, 1, 2, 3, and plot that point right there. 1, 2, 3, boom. And that's going to be the 3 square root of -1. 3 square root of -1. Now, in order to do negative square root of -1, I'm going to go down 1 and plot that point right there. Okay, so again, we've got the real number line, and we're moving off of it. This is not just your XY axis. This is actually like a number line and moving away from it. -5 square root of -1 is going to be down here. We're going to go down 1, 2, 3, 4, 5, and we're going to plot that point. Okay, so really understanding, hey, square root of -1 is off the real number line. Okay, so now we're going to introduce a new number system. Okay, so we're going to talk about imaginary numbers. That's where this square root of -1 is going to come into play. So this is probably the most important part of this entire unit. Okay, so again, if I were taking notes, this is what I would write down. I would say x squared equals -1 has 2 solutions, and square root of -1 is one of them. Okay. The square root of -1 is equal to I. And I squared is equal to -1. Okay, so I would write down everything that's circled. And even though it's on your packet, I would rewrite it because it's important. Right, so I'm gonna give you, so write these imaginary numbers using the number I, okay? If you ever see a negative underneath the radical, we know for a fact that there's going to be an I in our answer somewhere. Okay, well, what's the square root of 36? Okay, so this is going to be 6I. So notice how, since there's a negative underneath the radical, that turns into an I, and then we just take the square root of whatever the number is. So like on number 2, we've got a square root of -10. So we know that I is going to be in our answer somewhere. If we take the square root of 10, we're going to get some decimal, right? So, and we can't simplify that anymore. So we're just going to leave it as, that was an awful square root. We're going to leave it as the square root of 10. So we have I square root of 10. Okay. Now these two have been positive so far. On these next two, there's a negative out front, and you're going to keep that negative when you write out your answer. Can you try 3 and 4? Okay, so on this next one, I know that there's going to be a negative, and I know that there's going to be an I in my answer. Well, what's the square root of 100? 10. So I'm going to pull out that 10. There's a negative out front with an I. A lot of people like to write this answer as square root of 10. No, once you take the square root, pull it outside the radical. Okay. On the next one, we have negative out front. We also have a negative underneath the radical. But what's the square root of 17? It's some decimal, right? We can't simplify that anymore, so we're just going to leave it as the square root of 17. So we got, bless you, we've got negative I square root of 17. Makes sense so far. Okay, hopefully it's nothing too crazy. Now, if we wanted to add real numbers and imaginary numbers, we're going to call that something like complex numbers. So again, if I were writing notes on my paper, I would say complex numbers, and I would say this box right here, okay? The real part is this A term, and this imaginary part is going to have that I. So this would be an example like 2 plus 3i. Okay, where 2 is the real and 3 is the imaginary part. Again, if I were writing out notes, that's what I would write. Complex numbers, you got a real part, you got imaginary part. It's got this A plus BI, and that is our standard form. Good. Okay, so let's get some practice simplifying these complex numbers. Okay, so taking a look at this one. Okay, I want you to write these complex numbers in standard form. For instance, standard form, remember, is A plus BI. So I've got my real number first, which is this 2. And then I want to simplify this and rewrite it in terms of I. So I know that there's going to be an I. And what's the square root of 9? 3. So this is going to be 2 plus 3i. Again, hopefully nothing too crazy. We're just simplifying it, kind of rewriting it. Now the next one, we've got 5 is our real part. We've got a minus sign in between, and we're going to keep that. And then we've got the square root of 75. Don't remember from Finding Nemo where he was like, hey, you got to have your exit bunny in order to exit like the East Australian coast, right? He's like, do you have your exit? Y'all know what I'm talking about, right? Yes. Y'all have never seen Finding Nemo? Okay, so your homework tonight is to watch that. That's your homework. Yes, you can tell your parents I said that. Okay? My homework is to watch Finding Nemo. So he's like, hey, you can't exit unless you have your exit buddy, right? Okay, so what are factors of 75? Factors of 75?
15.
Okay, let's do 5 and 15, right? Yeah? Okay, can I break 15 down anymore? Into 3 and 5, right? Okay, now you can only exit the radical if you have an exit buddy, right? So there's a pair of 5s right here. Okay, so we got a 5 here and a 5 here. So that means I can exit the radical, and what am I left with? A 3. So I can rewrite this square root of 75 as 5 square root of 3. Okay, so this will be 5 square root of 3, and we had this negative underneath the radical, so that's going to be an I. Okay, I hope you remember this from Algebra 1. If you don't, that is how you do it. Okay. I want you to take a moment. I want you to try 3 and 4. See if you can simplify those. All right, so let's check in on number 3. So what's the real part of number 3? Is it just 6? Negative 6, right? Okay, it's got that negative chilling out front. Okay, and then what's the square root of 16? 4. So we know that it's going to be 4, and we got this negative underneath the radical, so that means that there's going to be an I. So I got negative 6 plus 4i. Okay. Questions on that one? Okay, so everybody's okay. Okay. On number 4, what's the real part? Is there a real part? No. So that's going to be 0 for the real. And it's okay if you didn't write 0, that's fine. Okay. And then you're going to break down this 12. Well, we know that there's going to be an I. Okay. And when we break down 12, we can break that into 4 and 3. And then that can break down into 2 and 2. And when we pull out our exit, buddy, I'm sorry, I'm writing down at the bottom. I'm going to get 2i square root of 3. Okay. How many of y'all got that right? Yes. Okay. Great. All right. So let's do a quick check really quick. What you're going to do is you're going to simplify this and write it in standard form. Do you want to go back? Are y'all good? Okay. So you're going to rewrite this in standard form. Okay. So go ahead and take a second. I'm going to give you about 2 minutes and then we're going to go over it. Yeah, go ahead. Okay. Which is the real part? Which is going to be the real part? The first one, right? Okay. And the reason why is because that negative underneath the radical, that's going to make this imaginary. Okay. So for this first part, what's the square root of 16? 4. So we're going to have a negative 4. For the imaginary part, we know that we're going to pull out an I. And what's the square root of 49? Okay, so we're going to have negative 4 plus 7i. Everybody see how I did that? Are there any questions over this? Hopefully this is not too bad. Yep. The square root? Yep. So if it's inside, this negative is inside the square root, that's when we're going to have this I. When it's outside, we're not going to have an I. Okay, so I know you can't really see this that well on your paper. So I'm going to zoom in so that way we can work on it together. Just kidding. Okay, so what you're going to do here is you're trying to match up the square root that corresponds to simplified version. Okay, so for instance, this is the square root. This is the question that they're asking. When I simplify this, I'm going to get, what's the square root of 81? 9. And we know that it's negative underneath the radical. So that means I'm going to get an I. So this will be 9i. So you're going to circle the two things that go together. On the next one, we have square root of negative 3. And if we simplify that, that's going to give us I square root of 3. You don't want to write the I at the end like this middle one is. That's wrong. Okay. So I want you to take a moment. I want you to try these next 4, and then we're going to go over the answers in just a second. All right, so just for the sake of time, and I feel like we can go through it together. So this is the question, right? And if I simplify this, that would give me this 5i square root of 5. Okay. Again, this is the question over here. If I simplified this, this would give me 4i square root of 7. If you put this one, that's close, but you can simplify it even more. Okay. The next one, that's going to give me 3 plus 8i. On the next one, that's going to give me 10 plus 6i square root of 2. Okay. Tomorrow, I'm going to teach you how to do kind of like a little cheat code way to do this. So if you're struggling with like simplifying them, that's okay. Tomorrow, I'm going to make it a little bit easier. Okay. What I'd like for you to do is on your paper, I want you to summarize the difference, the similarities and the differences between complex numbers, real numbers, and imaginary numbers. And I'm going to put it up on the board in just a second. Okay, so the similarities and the differences between complex numbers, imaginary numbers, and real numbers. Okay, so This is the diagram that is probably on your paper. I'll zoom out really quick. Okay, and I want you to write a sentence along each of the triangles that connects the two topics. Then in the center, write a sentence that summarizes all three topics. So how are complex numbers, real numbers, and imaginary numbers connected? Okay, so take a moment. You're working on this.